So this video lesson is going to be all about number properties, or at least what we call number properties. So the first thing we need to figure out is what do we mean when we say number properties? And so if we break that phrase into its two parts, number and properties, a number obviously is something that we're very familiar with. So I want to focus on the word property, at least when it comes to the meaning of property that we have in math. And a property of something in math is just something that is always true for whatever you're talking about. In this case, we're looking for things that are always true with certain sets of numbers. Now I can give you an example of some number properties that you're familiar with but have never thought about it like that. An even number, 2, 4, 6, 8, 10, etc. We know that an even number is defined by a number that is divisible by 2. So a property of an even number then is when you divide it by 2, you get an integer. You don't get a fraction, you don't get a decimal, you get an integer. And this is actually also true, I don't know if you've ever thought about it, when we go into the negative integers too. Negative 2 divided by 2 is negative 1, as we learned in the multiplying and dividing integers video. And so it follows the same rules in the negative integers as in the positive integers. So one of the properties of all even integers is that when they are divided by 2, they give you an integer. And there are some other things involving properties that we will talk about later on in the year. But in this case, we're not talking about properties of just the even integers or just the odd integers. Let me get rid of this over here for a second so we have some space. We're talking about properties with the way that the numbers are combined. So we're actually going to talk about some properties that are true with addition. We'll get to, not in this video, but in class, how they relate to subtraction, about multiplication, and again in class about how it relates to division. But really, some things that are true with numbers always when we involve addition and multiplication. So really maybe we should call these operation properties, because after all, we are talking about the operations, addition and multiplication, but we really do actually just call them number properties. So let's look at the first one. You've seen these properties before, at least you should have seen these properties before. You know intuitively that these are true, so we're just going to go through a little bit with the definition, explore the first ones first, and then go through the second one. And so the first one we want to talk about is called the commutative property. Now if we look at the word commutative to try to understand where the root comes from, we see the word there, commute. And to commute means to move from one place to another. So if we have an example of an addition problem, say 3 plus 5 plus 8, which we will use as our addition example for both this property and the next one. If we think of the idea of commutative property as in the word commute, which means to move, the property says that we can add these numbers up in any given order. So let's look at this on a number line. We're starting with 0, and I'm just going to mark this in hash marks of 2 so that we can go through and we can see what it is that we're talking about. So let's add these numbers up in different orders. So in green, we're going to add 3 plus 5 plus 8. And we're going to use the arrows on a number line like we did in the adding and subtracting with negative integers videos, so they can see how this addition moves through the number lines. So first, we have a plus 3. We're going to add 5 onto that. And then we're going to add 8 onto that one. So for us, 3 plus 5 plus 8 is equal to 16. Now in yellow, we're going to move things around a bit. We're going to say 5 plus 8 plus 3, maybe, and see what happens. Well, if we start with 0 and move up 5, 5 plus 8 is 13, so we need to go all the way up to 13. And finally, up again, it turns out 5 plus 8 plus 3 is also 16. Let's look at this in one more orientation to make sure that it really holds true in every order. In this case, we're going to say 8 plus 5 plus 3. We're going to start with 0, go all the way from 0 to 8 to start off with a jump of positive 8. 8 plus 5 more gives us also to 13. And finally, 3 more gets us to 16. So it should become obvious based on these few examples here that no matter how we add 3 plus 5 plus 8, we will always end up with a sum of 16. And in general, this is going to be true for any set of positive or negative integers that you add together. You can move them around into whatever order that you want to, and you will always have the same sum. And if we think about this very intuitively, we can look at it visually as in jumps on a number line, but we can also look at it as it makes sense that if you have a series of things and you combine them, particularly with numbers where you're adding them, in the end, if I have, let's use a concrete example here. If I have 8 oranges, 5 oranges, and 3 oranges, it should make sense that no matter what order I put them into piles in, if I combine these 3 piles into one giant pile of oranges, you should always end up with the same number, no matter what order you add them up in. Slightly more difficult to see in terms of this very concrete visual example is the commutative property of multiplication. We're going to use a fairly simple example here because we don't want to get into terribly high numbers when we talk about this, but let's say 2 times 3 times 4. And this is difficult to show visually on a smartboard in a 2D space, because to show it visually we would need 3D, but I'll see what I can do about some examples over here. So if we look at it first at 2 times 3 times 4, and go from left to right following the order of operations, 2 times 3 is 6, times 4 is 24. Let's change it around a little bit and see how we do. 3 times 4 times 2, 3 times 4 is 12, 12 times 2 is also 24. And one more example, 4 times 2 times 3, 4 times 2 is 8, and 8 times 3 is 24. So from this example, hopefully you can see and remember the idea that no matter what order you multiply your factors in, you should end up with the exact same product. Now, if we wanted to look at it visually, it wouldn't be on a number line. We would have to look at it and 2, 3, and 4 a little bit as a 3D shape. So if we start out with a 2 times 3, where we have a rectangle that is 2 blocks by 3 blocks, here in 2nd, 3rd grade, we start learning that 2 times 3 and 3 times 2 are always going to be the same product. We call that a turnaround fact. And so for two numbers like this, the idea of commuting them or changing their order makes sense because we can do that. So if we have, on one hand, 2 times 3 times 4, we can just switch 2 of them at a time to make them in whatever order that we want. If we wanted this to become 4 times 3 times 2, we could just switch these, switch the numbers again, so it becomes 4 times 2 times 3, and then switch these numbers one more time. We can do that over and over and over, and we can change from one number to another just using the 2-digit or 2-number commutative property that we learned when we first started talking about multiplication. On the other hand, if we look at it in 3D, then that extra 4 needs to become a 3D shape. That is 1, 2, 3, 4 blocks long. So we'll look at a concrete example of that, a 3D example of that when we get to class. But for right now, on the video, my drawing will just have to do. So the commutative property then is that the addends can be added in any order, and the sum remains unchanged. As you saw, 3 plus 5 plus 8 can be combined in any order, and the sum remains the same. Whereas in multiplication, the factors may be multiplied in any order, and the product remains unchanged. And we went through a bit of an explanation of why that works. Now for the associative property, which is the next one, I'm just going to take you through the definition because your problem for the end of this video lesson is going to be to explain to me why the associative property works. Now you're familiar with this property, you've seen it before. So I want you to start thinking about, as you look at this, why does this work? And basically, we have 3 plus 5 plus 8. I'm going to write it twice using that same example as we did before. The associative property says we can group them in whatever order we want, and the sum will be the same. So if we add the parentheses, which as we remember changes the order of operations and brings us to highlight something that we need to do first. So in this case, 3 plus 5. And in the case of the second example, 5 plus 8. Well, 3 plus 5 is 8, and 8 plus 8 is 16 for addition for the concrete example here. If we look at the addition now with the different parentheses, 5 plus 8 is 13, and 3 plus 13 is 16 also. So this is an example of the associative property. The way that you combine the addends does not change the sum that we can see with the example that we used here. Now, any single example is never proof that a property holds true all the time, but we know we've learned this before, and I'm just giving you an example to remind you of what it is. The same thing is true in multiplication. Let's use our example before, 2 times 3 times 4. And now if we wanted to group it in two different ways, we'd start with grouping the 2 times 3, and now grouping the 3 times 4. So 2 times 3 is 6, times 4 is 24, and on the other side, 3 times 4 is 12, and 2 times 12 is 24. Again, just one concrete example to remind you about the associative property, what it means, and how it works. So if we write it down formally with a definition, then we have addition is changing the grouping of the addends will not change the sum, whereas in multiplication, changing the grouping of the factors will not change the product. So we're going to get through to some natural extension questions of this when we meet in class. But the first thing that we want to say about this video lesson, because it's a property of numbers, it's not things that we actually do calculations with. We're actually not going to have practice problems, but we do have something. There is actually homework that you have to do. And what I want you to do is answer one of the following two questions in your notebook. The first question is, why does the associative property of addition hold? When we say, why does a property hold, we mean, why does it work? Why is it always true? So on one hand, I want you to think about the associative property of addition and write down some thoughts on why you think this property holds. It doesn't have to be anything formal, but I want you to write down some thoughts and see if you can justify to yourself and then eventually to your classmates when you get to class why the associative property always works. And then the second question is, maybe you want to do it with the associative property of multiplication instead. Maybe you're more comfortable with multiplication than you are with addition. That is perfectly fine. But choose one of these two questions. Answer why the associative property of addition holds or the associative property of multiplication holds. And see what you can get for when you come into